have 4 days left of in-class review for your final. So we'll do most of the day 5 ones. Day 6, again, we're only doing 2 of those questions because we omitted a lot of those topics. And then day 7 is where I suspect we're gonna have the most difficulty. So I wanna start those today as well. As far as the week goes, tomorrow is your last really small little final exam quiz as well. And your homework is placed on your desk right now. So those are the homework questions that you're gonna complete that are due when you return next Thursday. Okay, so I am going to start right here at day 5, number 1. And those of you that have passes, just get up when you guys need to. And anything that you missed, you can watch later, because I'll record all of this. And we need to start right at your ratio test question. All right, so right in your day 5, and you're probably gonna want your formula sheets out too. So number 1 asks you to use the ratio test to determine if your series is going to converge or diverge. So ratio test is when you write your formula. So I am going to go A sub n equal to, and if you look at your formula, you're going 1, 2, 3. So I've got n divided by, and then this is like 2 to the first right here, so sometimes that's helpful. So this is going to be 2 raised up to the power of n. Then you're going to go do your next one. So your next formula is the next consecutive term, which is n plus 1. So that would be written as n plus 1 divided by, and then 2 raised to the n plus 1. All right, so you've got your 2 formulas. Then you're going to do your limits. So you're going to do the limit as n approaches infinity of your formula for a sub n plus 1 divided by your formula for a sub n. And this would be in, your long answer portion of your final exam, so where you have to actually show all of this work out. So like a 4-point question kind of thing. So I have here my formula, so I'm going to go n plus 1, and then divided by 2 raised to the n plus 1. And this would be all over n divided by 2 raised to the n. And then I'm going to go up and do keep, change, flip on this. So first one stays the same. You have n plus 1, and then divided by. It's helpful to distribute this, so I'm going to write this as 2 to the n, and then 2 to the first, and then flip the other one, which gives me 2 to the n divided by n. And then you're going to take these and you're going to cancel. All right, so if you think about your canceling here, I can get rid of 2 to the n, and you're left with n plus 1, and then divided by 2 times n. And then again, we're taking the limit as n approaches infinity. And at this point, you do not have to show that work algebraically if you just know this limit is 1/2. You guys know that at this point? I would hope so. So here's the 1, here's the 2. So this limit right here would just be 1/2. And anytime you get an R value less than 1, this is going to be a series that converges. So that would be your answer with all of your justification. Okay, first one okay? All right, don't be shy, ask questions when you've got them. So number 2, you're going to write this in sigma notation. So sigma notation means your big E, and you're going to determine whether this is arithmetic or geometric. So this has a common difference of 2. So this type is going to be arithmetic. So I'm going to go a sub n equal to a sub 1 plus d, and then n minus 1 here. So I have a sub n equal to, you're going to plug in the 3, and you're going to go 2, and then n minus 1. So distribute this, and you're going to get a general formula in terms of n. So 2n minus 2. So your formula simplifies to 2n plus 1. So now you're going to draw your sigma notation. where your formula is written as 2n plus 1. You're going to figure out how do you get these terms. So how do I get a 3? Plug in a 1 here. And then you're going to think, how do you get 15? So 2 times what plus 1 will give me 15? 7. Yep, so that's it. That's all you got to show on that type. Good there? Okay. So 13, find the 14th term of the binomial expansion. So when you are asked for a particular term only, you're going to take this. And if you don't want to write everything out, this is always going to just be one less. So I'm going to start this as 21, choose 13. That was fast. Oh, okay. That's okay. No problem. Get up when you need to, okay? Yeah. So I take my first term, and I'm going to raise my first term to be 21 minus 13. And then I'm going to raise my second term to 21 minus, again, whatever that would give me there. So that would be 8. All right, so I have 21 choose 13. And then this is going to be x raised to the 8th power. And this would be 2 raised to the 12, 13. All right. Then what you're going to do is use your calculator, type these in. All right, so 21 choose 13. So go math over to probability. So 21 choose 13 is large 200, 3,490. And then I have x to the 8th. And 2 raised to the 13th power gives me 8,192. All right, so your answer, 8,192 is, I have 1 followed by 3 6s, 9, 9, 0, 0, 8, 0 times x to the 8th power. Okay. The expansion's okay? They're not bad, it's just a little pattern. Okay, so number 4 is just calculator work. So to get your factorial, you're going to hit the math key. And I don't need you to show anything for this. So I'm going to go alpha y equals enter. And I'm going to go 5 factorial. So that's over to probability. And then 4 factorial. So math over choice 4. And this was divided by, was it 2 factorial? Thank you, appreciate that. So 2 factorial back over and answer 1,440. That's it. Just making sure you know how to use that again. So that's just calculator math over to probability. And that was option number 4. So 1,440. Okay, so back up the next column now. Write the general form of the equation of an ellipse. All right, so to do your ellipse, this is going to be a completing the square question. So I need to get the 4x squared together with the 16x plus the 9y squared minus the 18y. And I'm going to take my constant and place it on the other side. So because you were given the general form, we want to put this in the standard form. And again, this is your completing the square process. So I take out a 4. I've got x squared plus 4x plus 9. And then I've got y squared minus 2y equal to 11. And now you're going to do your completing the square. So you're going to look at the 4. You're going to take half of it to get 2, square it and get 4, and you're going to place it right in that parenthesis. So that gave me a 4. And then when I go over to the other side, what I have to remember is this is 4 times 4. So on the other side, I'm going to add on 16 to keep my equation balanced. Over to the other side, I go 9y squared minus 2y. So half of -2 is -1. -1 squared is 1, which means that 9 gets added to the other side. All right, so you continue, you factor these. So I have a 4 times the quantity x plus 2 squared plus 9. And then this is y minus 1 squared equal to 36. So standard form for the ellipse means that this needs to be equal to 1. So I'm going to take everything and divide by 36. So divide by 36 all the way through. And this is your first answer. So my equation is going to say x plus 2 squared over 9 plus y minus 1 squared over 4 is equal to 1. Okay, so that is standard form right there. So this is your answer for standard form. Now what you want to identify, because this is an ellipse, is which axis represents your major axis. So I'm going to look right here, and the 9 is underneath my x squared. So I have a horizontal major axis. So we have a horizontal major axis. So this value is currently representing a squared. This one's b squared. So a squared is equal to 9, indicating that a is equal to plus and minus 3. And then b squared is equal to 4. So that means b is equal to plus and minus 4. I'm sorry, 2. And those values you're going to use in a second. I was just kind of utilizing that space while we had it. So before we find your vertices, we'll state the coordinates of your center. So my center is located at -2, +1. And now you're going to find the vertices. So your A value gets added to your horizontal because that is your major. So I'm going to go -2 plus and minus the 3, where the y stays the same. So my first two vertices are going to be 1, 1. And then my next would be -5, 1. Next vertices, so I'm going to grab my center. So I would go -2, and then I'm going to go 1 plus or minus the 2. So my last two vertices would be -2, 3. And then I have -2, -1. Okay, so your ellipse is going to have the 4. Next, I'm going to find the coordinates of the foci. So this is the equation that you have to have memorized. So c squared is equal to a squared minus b squared. So c squared is equal to, a squared was 9, b squared was 4 from above. So c squared is equal to 5. And therefore your c value is equal to plus and minus the square root of 5. Again, you had a horizontal major axis, so this is going to get added and subtracted to the x. So this value goes to your x value. All right, so my coordinates here, where is my center? Right up there, -2, 1. So center was at -2, 1. So therefore your foci, so your first foci is going to be at -2 plus the square root of 5, comma 1. And then your second would be -2 minus the square root of 5, comma 1. Okay, or you could leave them together too. It makes no difference to me. If you want to just leave it plus and minus, that's fine. All right, last we're gonna graph this. We're just gonna graph the center and your vertices. So just a quick sketch here. So I am centered at -2, +1. And my vertices are -2, 3, -2, -1. And my other two vertices from above were 1, 1 and -5, 1. 3, 4, 5. And your ellipse is going to look like this. All right. So horizontal major axis on that one. Questions on anything on the front, guys? Okay, so over to the back. I think this is where we start skipping around a little bit. Not quite, but number 7, you can definitely cross off. We're not doing that. So number 6 says, write an equation of a line in slope-intercept form. So this is y equals mx plus b. Whose parametric equations are x equals 2t plus 3, y equals t minus 4. How you want to approach this is you want to solve both of these for t equals so you can set them equal to each other. So you're going to solve each of these for t. So I would have x minus 3 equal to 2 times t. And then on the other side, I'm going to have y plus 4 equal to t. So I'm going to divide by 2, divide by 2. So t is equivalent to x minus 3 over 2. And over here, t is equal to y plus 4. So next step is you're going to take these, set them equal to each other. So I'm going to go x minus 3 now over the 2 is equal to y plus 4. I'll go over 1 for consistency. And then at this step right here, you're going to solve for y equals. All right, so you're going to just take this, cross multiply, solve. So I have here x minus 3 equal to 2y plus 8. I'm going to subtract my 8 over. And then lastly, divide this by 2. So divide by 2, divide by 2. So I have y equal to 1/2 x minus 11 over 2. All right, so that would be your final solution there. That is in slope-intercept form. All right, on that sheet, I'm going to go right on over to number 8. So look across to number 8. We want to find the 10th term of the geometric sequence. So this is formula sheet. Your formula for an explicit term of a geometric sequence is a sub 1 times r to the n minus 1 power. And all you're going to do is simply plug that back in. So I have a sub 10 equal to, I have the radical 2, ratio is radical 2, and then this gets raised up to the 10 minus 1. So just nice quick calculator work on that one. And if you type that in, you should get an answer of just plain 32. So a sub 10 equal to 32. Again, nothing more than calculator work there. All right, so number 7, you may omit. You don't need to do any of this. Those of you that just came back in, we are on the back of day 5 review. So now that brings me to 9. 9, I want to find the sum of the series. And what you're going to notice is this is an infinite series because you've got the dot, dot, dot. So you're going to look at your formula sheet. And this is about, so it's on the left-hand side of your formula sheet, pretty much all the way at the bottom. So the sum as we approach infinity is equal to a sub 1 divided by 1 minus r. And all you have to do is substitute this in. So my a sub 1 is 1 over 25. And then I'm going to go 1 minus And if I look at what's happening here to my denominator, I'm multiplying by 10. So my ratio is 1/10. All you have to do is take that fraction, type it in your calculator, and I get an answer of 2 divided by 45. So that's it. Just to refresh your memory as well, these are only possible when your R value is less than 1. So R in this case was equal to 1/10, and R was less than 1. So this one was possible. Otherwise, you could just say not possible. Okay. Questions on anything down to 9? Okay. Number 10. This one, it's been quite some time since you've seen it. It says to write the equation of the tangent line. So when we did your tangent line, this would be all the way back to chapter 8 when we did your projectiles. And this is going to entail finding the derivative to get your slope. So this is a derivative. So I'm going to take y equals first. And you just did derivatives last week when we did your projectiles to find the maximum height. And I do the derivative. So my derivative, so I go power down in front. So 2 times the -3 would give me a -6x, because you drop 1 from your power, and then -2. And the derivative of 5 was just plain 0. Good. The next thing you're going to do is you're going to find the slope. So to find the slope, you are going to replace the x with the 2 from the question. So you're going to sub in x equals 2 to the derivative. So I go -6 times this number right here, which is a 2, and -2. Okay, so this gives me that my slope is -14. So you're almost done. Then it says to write the equation of the line. So to write the equation of the line, you're going to do point slope form. And then if you want to leave it like that, that's no problem. So I lastly do point slope form. So point slope form is y minus y1 equal to m and then x minus x1. And all you're going to do is substitute in for y1, m, which we just found with your derivative, and x1. And then that's it. So if you want to leave your answer like this, that's fine. So I'm going to go y and then minus -11. So this would be y plus 11 is equal to -14, x minus 2. Done. So if you'd like to leave it like that, that's no problem whatsoever. Is there anything that needs further clarification on day 5? Okay, so over to 6. You're only doing 2 of these questions. So on day 6, I mean, if you want, you can cross everything off, or you can just do the ones that we're going to complete. So we're only going to complete 3 and 4. So you're not responsible for anything else on this sheet. So number 3, it says write it in expanded form and find the sum. So you're just going to do this out. So I'm going to first plug in a 3 here. So I would have a 3 cubed minus 3 times 3. So that's my first term. And I'm going to do this just to keep it all together. And then plus. Then I would go 4 cubed minus 3 times 4. And then one more of these. So plus, I stop at 5. So 5 cubed minus 3 times 5. And then all you need to do is place this in your calculator. So you could type it just like it appeared like that. And answer comes back as 180. So your expansion, this would be your answer right here to part A. You don't have to recopy it unless you'd like to. And then that adds up to 180. So next, number 4. Same thing, write it in expanded form, find the sum. So this time, my first term is indicated by 0. So I'm going to plug in the 0 to get the first term. So this would be 5 times 0.2 raised to the 0 plus, and then 5, and then the next one would be 0.2 raised to the first. And obviously, because this goes to infinity, we can't find the end of this. So you're just going to end this one, your expansion, with dot, dot, dot. And then we'll use the formula to find your sum. So same formula we just used a couple questions ago. The sum as we approach infinity for the geometric series is a sub 1 divided by 1 minus r. So this term right here is your first term. 2 to the 0 is 1 times the 5 is 5. And that's going to get plugged in there. So I'm going to do the sum as we approach infinity, which is equal to 5 divided by 1 minus 0.2. All right, that goes in your calculator as well. And your answer is 25/4. So 25/4. Okay, that is it on that sheet. Do we feel okay with those two? Okay, now over to 7. We're not going to do all of these today. We're going to do some of them though. I would strongly recommend that your formula sheet is right next to you. Okay. These are your trig concepts. Again, I anticipate this is where we're going to have the most questions, and you probably would feel the worst just because this is the furthest content back. You know, this was close to when we did your midterm. Does everyone still have a formula sheet? Okay, and again, feel free to write all over that too, because you'll get another one of those for your final. But you're going to use all of your trig content to do these questions. So on your formula sheet, you're looking at the right-hand side for these. So number 1 says to simplify. So I have secant of x times cotangent and sine of x. So just as a quick refresher, what's secant the reciprocal of? Do you guys remember? Cosine, good. Cotangent goes with tangent, and then sine obviously is what it is. So your first step here would probably be to distribute. So I'm going to go secant of x, cotangent of x, and then plus, I'm going to go secant of x, and then times the sine of x. And what I'm looking to do is simplify this. So I want to be able to eliminate some of these trig functions. So I start and think about what can I substitute in for these. Did I give you your reciprocal ones on here? Yes, I did. Bottom left-hand corner. If you look all the way down there, you're going to replace secant with 1 divided by cos of x. Now, cotangent has 2 identities for it, and one is going to be more helpful here than the other. So cotangent, even though it's 1 over tangent, does that help you here? No. What else is cotangent? So close. It's not quite sine over cos, but it's cos over sine. So cotangent can be represented as cos of x over sine of x. And does that help? Yes, definitely. But I'll leave that off for a second. Now I go over to the next one. And secant is 1 over cos of x. And then sine is what it is. There's nothing simpler you can sub in for that. Okay. So you're going to keep going through this. So on the left-hand side, I think it's fairly obvious your cosines cancel. I'm left with 1 divided by sine of x here. And then your other side, I am left with sine of x divided by cos of x. And then you're going to finish this. So where I see 1 divided by sine of x, that is equal to cosecant x. And where I see sine of x divided by cosine of x, that is equal to tan of x. Done. Okay, so you simplified it. I'm going to go across. So over to number 6. Number 6 says to prove. So what you're going to do is work with one side and simplify it into the other. I typically like to work with the more complicated side. So I'm going to start this here. And we're going to plug in all your substitutions and show that we can obtain the left-hand side. So the first thing that might be helpful to do is take this and split it. So I'm going to rewrite it as 1 over secant of theta, and then times tangent of theta over secant of theta. So you just broke it apart, basically. Now, on the left-hand side, what can I go with 1 over secant theta? What can I replace it with? 1 over secant is cosine. So you already have that part. So you're halfway there. You know what you're trying to do here. Oh, why did I write times? I'm sorry, that's plus. Plus, that would help. So you're halfway. You're looking to find a way to turn that second fraction into a sine of theta. So start subbing in. So for tangent, I'm going to replace that with sine of theta over cosine of theta. And then for secant, I'm going to replace that as well. So secant is 1 divided by cos of theta. Okay, again, my left side is all set. I'm just going to rewrite it. And then what happens on this other part is I'm going to do a keep change flip. So I'm going to get a sine of theta over a cos of theta. And we're going to multiply this by cos of theta over 1. And then you're done. So this is all together still. And then what happens with cos of theta? Cancels out, yep. So I'm going to lightly cancel that one. And write what's left over here. So that cancels. And then that cancels. And I am left with cos of theta plus sine of theta. And that does match the other side. So I'll just do this. Check. You've proved it. You're good to go. And no, you don't need to rearrange it. It's fine. How do we feel with 6? The more you see these, the better. So number 2, I'm going to do it just like number 1. You're going to take these and you're going to multiply them. So I'm going to go sine of x times secant of x first. Just going to take care of this multiplication. Next, sine of x times cosecant of x. So keep going. Minus cos of x and secant of x. Minus cosine of x and cosecant of x. So next you're going to plug in your identities here and see if anything cancels. So I have a sine of x. And then where you see secant, I'm going to replace that with 1 divided by cos of x. Next, I'm going to have sine of x. And that's going to get multiplied by 1 divided by sine of x. Minus cos of x. And secant is 1 over cos of x. And then last, I'm going to go cos of x times 1 divided by sine of x. All right. Now you're going to cancel. Just switch colors. All right, so I am able to, well, I can't cancel this one, so I'm going to leave it like this for a second. So this just gives me sine over cos. Next, though, what happens with the sines? Yeah, good, it becomes 1. And then what happens with the cosines? Yep, -1. And then next I am going to have minus, and then I have cos of x over sine of x. All right, so obviously the middle part just goes away for you. So those you can cross off. And then my answer, so sine over cos is equivalent to tangent. And then cos over sine is equivalent to cotangent. There you go. So there's your simplified version. Okay, how do we feel on that one, okay? Again, the more familiar and the more you work with those reciprocals, the easier they become. So just keep doing them, and it'll become kind of intuitive. Number 3 says to simplify. Now, if you look at this, you will notice that both expressions share sine squared theta. So I'm going to GCF that out. So I'm going to write a GCF here. So I have sine squared theta multiplied by 1 plus cotangent squared theta. I'm going to look inside at my parentheses, and then I'm going to take a glance at my formula sheet. And on the right-hand side of your formula sheet, what can I replace 1 plus cotangent squared theta with? Did I see it? Cosecant, good. Oh, I just changed that to an x, I apologize. Guess it doesn't technically matter, but. All right, so sine squared theta, and then this is equivalent to cosecant squared theta, and then I can keep going. So I have sine squared theta, and then where you see cosecant, you're going to replace it with 1 over sine squared theta, and then what can I do with sine squared thetas? Cancel them. Yep. Again, when you've done these questions correctly, you're going to notice a lot disappears. So that's gone, that's gone. Solution's just 1. All right. So I'm going to do something very similar on number 7, but it just says prove instead. So I'm going to work with the more complicated side and show that I can obtain 1 from it. I'm going to, again, GCF cos squared x out. And that leaves me with 1 plus tan squared x. And again, anything that becomes a squared, those are called your Pythagorean identities. And that is your indicator to look at your formula sheet. So do I have something I can replace 1 plus tan squared with? Yep. So what is 1 plus tan squared equivalent to? Good. Yep. Secant squared x. And now you can keep going. So secant is a reciprocal trig function. So I'm going to leave this for cotangent for the time being and see if we can get it to cancel. So this is 1 divided by, oh, I'm sorry. Why did I change that to cotangent? Changed 1 little letter. You guys did not catch me there. There we go. Sorry, bad allergies with the contacts these days. There we go. Cos. Okay, so secant becomes 1 over cos squared x. And then did that help? Sure did. So then you're going to cancel your cosines again. And does this prove that you are equivalent to 1? Yes. So if you want to do something like this, you can. And then good to go. So you are equal. All right, down to number 4. So you want to simplify. Now, I have cos squared theta minus 1. I want you to think of that as like x squared minus 1. So this is actually difference of 2 squares factoring. So cos squared theta minus 1 factors into cos theta plus 1 times cos theta minus 1. And then divided by the bottom, I'm going to keep exactly the same because now you're done. So those cancel, leaving me an answer of just cos theta minus 1. Okay, so that is difference of 2 squares factoring with that. All right, so down to 5 and 8. I guess I'll do 8 first because it's kind of above the other one. Number 8 says, use your trig sum and difference identities to find the exact value. So these are all your special angles that you do have to have memorized. So I need to figure out how can I obtain 15 degrees with these special angles. So how do I get 15? Can't I do 45 minus 30? Yep, so that's one option and that works. So I'm going to look on my formula sheet now to where it says the identity tan of x minus y, because that's what I just chose. So I'm going to go tan of x minus y, which in our case here is going to be the tangent of 45 minus 30. And now I'm going to just sub those in. So I have the tan of 45 first. And then next it's going to say minus the tan of y. So that's minus the tan of 30 divided by 1 plus the tangent of 45 times the tangent of 30. Actually, the tangent of 45 is really nice. Do you guys remember? 1. Good. So this is equal to 1 minus the tan of 30 is not nice. So it's irrational radical 3 over 3 divided by 1 plus 1 times radical 3 over 3. And I'm just going to neaten this up a little bit. So on the top, I'm going to take the 1 and write it as 3 over 3 instead, which allows me to put these together. So I would have 3 minus the square root of 3 over 3. And now I'm going to do something similar on the bottom here. So the bottom, this would be a 3. So I would do 3 plus radical 3 over 3. And if you do keep change flip, what happens with the 3's? They cancel. Yep. So that's your solution right there. So these would cancel if you did keep change flip. And my answer you may leave as 3 minus radical 3 divided by 3 plus radical 3. Or if you want to rationalize it, you'd multiply top and bottom by the conjugate. I'm going to just leave it like that though, just because it gets kind of lengthy and I'm out of space. So done. Just what's important is please do not write it as a decimal. So leave it as an exact value. All right, so over to number 5. So number 5, I'm going to use trig identities to write it as a trig function with one angle. Okay, you want to find on your formula sheet what is equivalent to cos x cos y plus. So just look for that part first. So cos x cos y plus. You guys see what that's equal to on the left? So it's like, I don't know, 4th box down. So this is equal to cosine of x minus y, which means my answer is just going to be cosine of 72 minus 14, which is equal to the cosine of, that would be 62, and then minus another 4, cosine of what, 58? Done. Okay, so you just leave it just like that. So letter B, I'm going to do something very similar. On your formula sheet, you're going to look for what is this equal to on the left. So this says sine of something times cosine of something different. So that'd be cos of y. And then it goes plus. So you're looking on your sheet where it says sine x cos y plus. And if you look to the left-hand side, this is equivalent to the sine of x plus y. So this is the sine of 26 plus 70, which is equal to the sine of 96. And again, that's not like a special angle, so that's why you can just leave that one right like that. All right, how are those so far? Okay, so letter B, and then I think I'm going to stop there for today. So letter B, cosine of 165. This one's a little tougher. So if you think about your angles like 30, 45, 60, 165 might be more challenging to get with just two of these, if not impossible. So what you can do instead is I'm going to do cosine of 30, which is a special angle, plus 135. And the reason that 135 works is because 135 is over here. And what's the reference angle associated with 135? 45, yep. So you can still absolutely use those. So now I'm going to look at my formula sheet, and I want to add these together. So this is cosine of x plus y. So this is going to be your formula that says cos of x, so cos of 30, and then it says cos of 135, and then I'm going to go minus the sine of 30 and the sine of 135. And then I'm going to plug all these values in. Oh, I'm sorry. So I'm going to plug all of these in. So the cosine of 30 is radical 3 over 2. The cosine of 135 is that 45-degree reference angle. However, you need to recall that cosine is negative there. So this is going to be the negative cosine of 45, which is negative radical 2 over 2. Minus the sine of 30 is 1/2. And the sine of 135 is like the sine of 45, and it's positive there. Radical 2 over 2. All right, so there's your answer. And again, no decimals. So this is equivalent to the negative square root of 6 over 4 minus the square root of 2 over 4. You can leave it like that if you'd like, or you can put them together. So negative square root of 6 minus the square root of 2 all over 4. Okay, so just like that. Do you feel okay on those so far? Okay, so tomorrow, first half of class, we're going to finish this back part, and then you have a very quick 4-question quiz on days 3 and 4, and it's up to you this time to review those, okay? Very, very easy concepts. We did a lot with like your dot products. We did a cross product with your, your matrices. We did some of the polar rectangular. So look over days 3 and 4 tonight, please. And these problems we will finish up tomorrow. And your homework has been placed on your desk. They are all in that packet.